Welcome learners in our today's lesson. Today we're going to look at programming languages. Programming languages basically refers to different environments that will guide programmers on how to come up with computer programs. Remember, the programmer has to come up with knowledge, has to come up with a program, and you're saying the main aim of our program is to guide the physical devices of our computer on how to solve a given problem. So how can we command a hardware? And a hardware is a machine doesn't understand the normal language of a human being. So you need a language which you can communicate your formula, your solution to a given hardware, so the hardware can be able to understand. So these are example of programming languages, different languages or environments that programmers can use to develop computer programs. We shall start with machine language. So machine language was the first one to be developed. Under this programming language, the programmer uses what he calls zeros and ones, to write programs. And whenever you come up with a program, any general program has two components. Has what he call the operand part and what he call the operational part. The operand part and the operational part. The operand part of a program will focus on the data, guiding the hardware on how to acquire data. The operational part of our program will focus on if the computer has data, what it will do with those particular data items. For example, if we want to come up with sum of two numbers, it means on the operand part, I'll form lines that will get the computer on how to acquire two numbers, let's say 4 and 6. Then the operational part of our program of that, it means I'll form a line that will guide the hardware on what to do with these two numbers. For example, take number 4, which is the first number, then increase it to number 6, which is the second number. So this addition, if I'm forming a line on focusing on addition, it means that line is focusing on the operational part of our program. So I say this part will guide the hardware on what to do with what we call the data, and this part of our program will guide the hardware on how to acquire those data and where to locate those data items. So in machine language programs, all the two components of our program are written in zeros and ones, and these are language that our computer can understand. So any program written in zeros and ones, such a program doesn't require what we call translation, because this language is what we call computer language or binary language, which is a language that our computer can understand. So basically, all programs written in machine language doesn't require what we call translation. We move to the second programming language, which is known as low level. In low level, when the program is forming the operand part of a program, the programmer uses the normal English vocabularies. But forming the operational part of a program, the program uses what we call a keyword, which will form or will have a unique meaning. That given keyword is known as a mnemonic, and each and every mnemonic has a given function or operation. For example, if you want to add, I use add as a mnemonic. If you want to divide numbers, say div, you can say 4 div 5. It means you want to divide 4 with 5. If you want to multiply numbers, say mult, you say 4 mult 5. This is as 4 multiplied by 5. So we are saying in low level is where a program uses normal vocabularies to form the operand part of a program and uses mnemonics to form the operational part of a keyword. And we are saying a mnemonic basically is a certain keyword that has a predefined meaning and function where the hardware will understand. An example of mnemonic is add numbers, div to divide numbers, mult to multiply numbers. If you want to subtract, I can say sub. Subtract is sub, calculating the difference, what we call high and low level. So it means if I'm using the normal English vocabularies for the hardware to understand, because you see that the hardware understands what is written in zeros and ones. So any program written in low level must be translated, must be converted into zeros and ones. And we have a program that will convert. So this program is known as an assembler. So an assembler is a program that converts what we call a low-level language program into what we call machine language, so that the hardware can understand and execute. Hi, we move to high level, which is the third programming language. So in high level is a programming language where programmers use what we call the normal human natural language to come up with programs. So in high level, programs are written using the normal human natural languages, whereby if I come up with a program in high level, any human being can go through that program and that person can somehow understand some ideas. You can somehow understand some lines, not each and every line, but somehow. So programs are written using human natural language. For the computer to understand those programs, it means they must be translated. We say that low-level language programs uses what we call an assembler as a program that converts a low-level language program into machine language with zeros and ones. Now, on the other hand, high-level language programs uses what we call compiler and interpreter and a compiler. Those are examples of language translators. The difference between a compiler and interpreter is in this manner. Compiler, if I form a line, let's say I form a program, and my program has 5 lines, and these lines are written using high level, meaning using human natural language. If I'm using a compiler, it will convert all the 5 lines at once into machine language. If I'm using an interpreter, it will convert line by line. It will convert line 1, which is in high level, to machine language in zeros and ones. It will give it a file name. It will assign a unique file name. It will go and convert line 2 from high level to machine language, zeros and ones. It give it another file name, save it separately. So at the end of the day, I had one file which had 5 lines, but after translation, I come up with 5 different lines for each and every line. So interpreters work with another program known as a linker, and the work of a linker is basically to pick these separately translated instructions, which are in zeros and ones, to combine those lines into one complete program. We say that if I form line 1 in high level, line 1 will be converted as that one line alone into machine language and will be given or assigned a unique file name. It will proceed and convert line 2 into zeros and ones, and those line 2 will be assigned a unique file name. It will save it separately until it reaches the last line, which is line 5. And remember, these 5 lines came from one program. It's just one program. So we are saying the work of a linker is to access these separately saved instructions, which were translated from one program, and they became 5 lines, which are saved separately in form of 5 files. It will combine all those 5 lines into one complete program. So we are saying high level is where the program uses what we call human natural language to form programs, and those programs for the hardware device of a computer to understand, they must be translated using one compiler, another one is interpreter. And we are saying using compiler, it will convert all of them into zeros and ones at once. Using an interpreter, it will convert line at a time. Then you can proceed to 4th generation languages. These are programming languages that basically allows or enables the programmer to come up with programs that run on the internet. This one is for creating applications that run on the internet via what you call a web browser. Internet refers to physical connection of computers. So basically, for you to access anything on the internet as a resource, you have to have what you call a web browser. So a web browser is a program that displays any resource from the internet. So if a program wishes to come up with an application, a program, and for the user to access, utilize this program, it must have the web browser, it must have the internet. It means I apply 4th generation languages. For example, you want to come up with an application like Facebook that allows or facilitates users to communicate remotely. It means I can use this kind of programming languages to come up with Facebook, because you cannot access that source on Facebook without one, having a web browser on your computer, and number two, your computer must be internet enabled. That device I'm using must be able to access the internet because this resource is running on the internet. Then last, you have what you call fifth generation of languages. So basically, these are programming languages that are still in a state of development, although some of them are being applied, and the few that are being applied in this field known as artificial intelligence. Artificial intelligence is basically a branch of computer science. Is a branch of computer science that focuses on coming up with devices that behave like a human being. Artificial intelligence is a branch of computer science that deals with coming up with devices that imitate the human behavior, e.g. a robot. A robot is a device that can behave like a human being. It has the physical features in terms of hardware. It also requires knowledge or software. So robots are programmed using what you call fifth generation languages. And the work of a robot is basically to perform a task that is dangerous to human life. If let's say I want to do a research and find out what happens at the sun or the moon, I cannot perform that given activity because that activity is dangerous to human life. So I develop a device which can behave like a human being, then I program it, then I send it to that location to perform that given research. So basically we are saying that's an example of artificial intelligence. We can have what we call expert systems. Expert systems are those systems that allows users to harness. Harness means acquire knowledge. So you can acquire knowledge from an expert. For example, if you have a doctor who specializes in, let's say, spinal cord problems. This doctor is an expert in handling any problem that deals with spinal cord. So if this person dies, it means we can lose that knowledge. We can harness, we can acquire that knowledge from that particular expert, put on a machine. In case that person dies, we don't incur loss, and we can reuse that particular knowledge. So that system that is storing that knowledge and allowing patients to interact with that system, whereby if you have a symptom, if you have any problem with about spinal cord, you work with the system. Just give or enter the symptoms to that system. The system is able to diagnose and come up with a medication. So such a system is known as expert system. So these systems are in terms of the physical devices. They need knowledge. They need to be programmed. So programming these systems, we come up with programs that these systems uses using what we call fifth generation languages. So our structure programming is a style of programming which falls under high level. So when we are going to program using structure, the programming style, we are going to use human natural language to program or come up with lines, and those lines are going to be compiled. They are going to use a compiler as a language translator, because we are saying for the hardware device of our computer to understand, it means if I form a program in high level, it must be converted to machine language, zeros and ones, so that the hardware can be able to understand and execute. So basically that marks the end of our class today. Thank you.